We are starting with the yearly past paper revision of P3, Pure Maths 3, and we are starting with February-March 2020, the second variant. So let's get started. Let's look at the first question. The question says, sketch the graph of y is equals to x minus 2 modulus, and then it says solve the inequality. Now the very first thing is, if I want to sketch this graph, I need to draw the x-axis and the y-axis. I can draw the line y is equals to x minus 2 like this. So this is y equals to x minus 2 without the modulus. Positive slope, negative y-intercept, that is the graph. And now if I want to draw the modulus of this, what should I do? I should reflect this thing in the x-axis. So therefore the graph is something like this. I'm drawing it a bit more correctly. This one and this one, the green ones, that is the final graph. This y coordinate would be plus 2. This intercept would be when x minus 2 equals to 0, x is equals to plus 2. So these are the important things that you should label. So this final graph is y is equals to x minus 2 modulus. Now in the second part, it does not say hence solve the inequality. So I feel much comfortable solving it on its own. There is a modulus on the left hand side and something else on the right hand side. That doesn't make a difference. And secondly, there is a lesser sign. So I would apply the concept x modulus less than a. That is the same thing as x lies between negative a and positive a. So therefore x minus 2 modulus is less than 3x minus 4. In other words, x minus 2 lies between 3x minus 4 and 3x minus 4 with a negative sign. Solve this part separately. Solve this part separately, and then we would look at the final inequality. So on the right hand side, x minus 2 is lesser than 3x minus 4. X minus 3 is negative 2x is lesser than minus 4 plus 2, that is minus 2. Divide by negative 2, therefore x is greater than plus 1. That is one inequality that I get from this orange section. If I focus on the blue section, negative 3x plus 4 is lesser than x minus 2. Negative 3x, negative x, that is negative 4x is lesser than negative 2, negative 4, that is negative 6. Therefore, x is greater than 6 over 4, which is 3 over 2. Now, both inequalities are pointing in the same direction. So, first of all, this is the answer for the blue portion. Now, the thing is, draw a number line and label x is greater than 1. So, this is 1 and this is 3 over 2. And we have to choose the final answer. What is the final overall inequality? That is what we are focusing on. So now in this thing, we have drawn this particular thing. I'm just looking at one thing. Have I started with the right footing? Yes, that's the correct one. So now if I go to the right hand side, and this is x is greater than 1, that goes this way. This is actually this one, the orange one. X is greater than 1 going this way. X is greater than 3 over 2, that is going this way. Both circles are empty circle, which is the final answer. So let me choose a value from here. Let me choose a value from here. Let me choose a value 1.25. Let me choose a value 2. And plug them in the original inequality. X is equals to 1 versus x is equals to 2. 1.25 versus x is equals to 2. Original inequality is x minus 2 modulus. X minus 2 modulus is lesser than 3x minus 4. When I plug in 1.25 minus 2 modulus, that is 0.75, is it 3 times 1.25 minus 4? So that is 3.75 minus 4 is negative 0.25. Is this true? No, this is false. So that's the first thing that I have done. That means this particular region is false. Now I am focusing on the other part. The other part is plugging in x is equals to 2. So 2 minus 2 modulus is lesser than 3 into 2 minus 4. This is 0, lesser than 6 minus 4, which is 2. This part is true. That means what is my final answer? My final answer belongs to this region, So therefore the final answer is x is greater than 3 over 2. That is the final answer for this particular part. So now that is the first question. Let me label it. This question is about modulus graph and inequality. That is the first part for this. So now let's move on to the next one. It says solve the equation such and such, give your answer as a simplified exact form. This question is about logs. It's about a equation related to logs. Now in this one, ln of 3 plus ln of 2x plus 5 is equals to ln x plus 2 whole square. That is the first rule of log that I've applied. The second rule, ln 3 multiplied with 2x plus 5 is equals to x plus 2 whole square, ln of x plus 2 whole square. Now since there are two terms related with ln, one on the left, one on the right, so therefore what happens? 3 times 2x plus 5 equals to x plus 2 whole square. Therefore 6x plus 15, that is x square plus 4x plus 4. Take all the terms on one side, x square as it is, 4 minus 6 is negative 2x, and 4 minus 15 is negative 11 equals to 0. That is the first thing that you get. When you solve this quadratic equation, they are saying give the answer in the exact form. That means third form is applicable. That means you have to solve it using the quadratic formula. So a is 1, b is negative 2, c is negative 11, and apply the quadratic formula. X is equals to minus 2 plus minus 2 square minus 4 into 1 into negative 11 square root divided by 2 times 1. There is a plus 2 on the outside, and what happens on the inside? That's 44 plus 4. That is 44 plus 4 is 48 divided by 2. 48 can be written as, write it on the side, 48 is 16 times 3. That is root 16 root 3, that is 4 root 3. So that is what you get out of this. So what you get out of this, 2 plus minus 4 root 3 divided by 2. Either or, 2 plus 4 root 3 divided by 2. Therefore 1 plus 2 root 3. And this is 2 minus 4 root 3 divided by 2. This is 1 minus 2 root 3. So these are the two answers for this one. But there is one issue. It's asking for answer. This is singular. It's not asking for answers. That means you need to choose a value which is positive. Why? Because ln x plus 2, if this thing becomes negative, the equation is invalid. If this thing becomes negative, the equation is invalid. So 1 minus 2 root 3 This is a positive value, perfectly fine. This is a negative value. And when you plug this value over there, this is greater than 2. So this negative greater than 2 will eventually make it negative. So that is why we are rejecting this particular value. That is the answer for this particular part. Now let's read this question. What is this question all about? This looks like a graph question to me in the beginning. And what else is there? Verify by calculation. This is numerical solution of equation, and then iteration. So basically it's a standard question of numerical solution of equations. So now let's first focus on this part that is related to graph. So let me just get something so that I can comfortably place my iPad on it. And I think this is better than before. Okay, so now we are starting with this. That first of all, we need to show sec x is 2 minus half x. So this is the x-axis. This is the x-axis. This is the y-axis. And 0 to 90 sec. Sec is the reciprocal of cosine. Now I'm just doing a rough idea. This is cosine like this, or cosine is like this, minus 90 to 90. So therefore sec is like this. So I got the idea. So let me draw a line like this, and I can make it a bit dotted. So therefore the graph of sec would be something like this. This is the graph of sec x. This is 0. This is pi by 2 asymptote. This value is 1. This is y-axis. This is x-axis. And you need to draw, this is y is equals to sec x, this is 2 minus half x. So the y-intercept is 2 and the gradient is negative half. So let me draw another line like this. And it's cutting the y-axis at 2 with a negative gradient. And how many points of intersection? There is 1 point of intersection. So you would say 1 point of intersection means 1 root of equation. And label the individual graphs also. So when you label the individual graphs, which one is this? Of course the straight line one, that is y is equals to 2 minus half x, and the curve one, that is y is equals to sec x, and that's how this graph is drawn. Next part, verify by calculation that this root lies between 0.8 and 1. So the equation is sec x equals to 2 minus half x. Therefore sec x plus half x minus 2 equals to 0. Let this equation equals to fx, that is sec x plus half x minus 2. Plug in this root, let's call it alpha, lies between 0.8 and 1. Make sure your calculator is in radian mode. Angle is in radians. Calculate f of 0.8, calculate f of 1.0. One of them would be positive, the other one would be negative, and then you get your answer. This is called change of sign method. So now this is done. Part C. Use the iterative formula. You don't have to prove it, they have already done it. Cos inverse 2 over something to determine the root correct to 2 decimal places. Give the result of each iteration to 4 decimal places. So you would say the initial value is 0.9 because the root lies between 0.8 and 1. So mid value is the best point to start. That mid value is 0.9. Plug in over here, x2 equals to cosine inverse 2 over 4 minus 0.9. Now let me work out the first value. When we work out the first value, that is 2 minus 2 over 4 minus 0.9. So let me clear the calculator for a second. 4 minus 0.9 is 3.1. 2 divided by 3.1. And your calculator is in the radian mode and cosine inverse. So therefore this comes out to be 1.242. 4 decimal places, 1.2423. This is the first answer that you get. Try out again. x2 is 1.2423. Therefore x3 is cosine inverse 2 over 4 minus 1.2423. Use the 4 decimal place value. Minus 4. This comes out to be something like this. So 2.7577. 2.7577. 2 divided by 2.7577. Get the answer. Cosine inverse, and I think I made a small error. Hold for a second. Let me grab this thing. 4 minus 1.2423. 1.2423. And this comes out to be 2.7577. Now let me reciprocate it. Multiplied by 2. So therefore 0.7252, and then cosine inverse of this value. The value is getting a bit smaller. This is 0.7594. 0.7594. So there is a big jump. Let me plug this value in. 0.7594, and x4 is equals to. So this is 4 minus 0.7594, and then reciprocate it, and then multiply by 2, and then cosine inverse. So therefore this thing comes out to be 0.9057. We started with 0.9, it jumped to 1.24, then 0.75, then 0.9057. One more step to be done. So let's see. 4 minus this value, 9057, clear it. 4 minus 0.9057, and then reciprocate, and then multiply by 2, and then cosine inverse. So this is 0.8680. This is 0.8680. X5 is this value. X6 would be 0.8680. 4 minus 0.8680, and then reciprocate, and then multiply by 2, and then cosine inverse. So this is 8781. 8781. So it took a little bit longer than usual, and I think one more step is there. Yeah, I think this is enough, because it says correct to 2 decimal places. 0.8680 becomes 0.87. 0.8781 is becoming 0.88. Therefore I think one more step is needed. Therefore x6 is this value, and x7 would be giving the answer correct to 0.88 or maybe 0.87. So you don't know for sure what is the root of the equation. So the best bet is to start from the mid value. Second important scenario that is to be learned over here. I started with 0.9. I got a value 1.24. I started with 1.24. I got a value 0.75. So sometimes this kind of fluctuation do happen. And then it was converging to a value. Let's look at the next question. What is this question about? This question is definitely about integration. And which kind of integration is this? This is integration by parts. One single question worth 7 marks. Now, in this particular question, remember the concept: u dv integral, that is uv minus integral v du. This is the concept that is to be used over here. Second concept, the concept of LATE. This is the order for choosing u. L for log, A for algebra, T for trig, E for exponential. So what do we have over here? We have algebra and trig. So we have u is algebra and dv is trig, that is sec square x dx. Whatever you take as u, you differentiate it. So du is 1 dx. Whatever you take as dv, you integrate it. So integral of sec square is tangent. Follow the arrows. So therefore the first step is x tangent x minus integral tangent x dx. That is the first step. Now how would you integrate tangent x? Tangent can be written as sine x over cosine x. And is the numerator derivative of denominator? Almost. There is a minus sign missing. So this is negative ln cosine x. In case you are wondering which rule was applicable, it was f prime x over fx dx. Therefore the integral is ln of fx plus c. So therefore this minus sign is already there, and then there is minus ln of cosine x, that becomes plus ln of cosine x, and this is still x tangent x, and the limits are pi by 6 and pi by 3. Pi by 6 lower, pi by 3 upper. This is pi by 3 tangent of pi by 3 plus ln of cosine of pi by 3. This is the upper limit, minus pi by 6 tangent of pi by 6 plus ln cosine of pi by 6. So a beautiful question is waiting for you. First of all, tangent of pi by 3 is root 3 and tangent of pi by 6 unrationalized is 1 over root 3. Cosine of pi by 3 is half. Cosine of pi by 6 is root 3 over 2. So exact ratios are applicable over here. That is why you are getting those 6 marks. The integration was not so difficult. There were 2 integration, the by part and then tangent. Then it's all about the ratios. So this is pi by 3 multiplied with root 3, and this is ln of half minus pi by 6 into 1 over root 3, and I can also use the other form, which is root 3 over 3. Let me use that form. So this is root 3 over 3. This is the rationalized form. This is root 3 over 3. I'm using this form. And let me push it to the side. And then we have, what do we have? This is one bracket. So let me make it a bit smaller. Like this, minus ln of root 3 over 2. So now this is pi by 3 root 3 minus pi by 6 root 3 over 3, and this is ln of half, and this minus minus becomes plus, that is ln of root 3 over 2. Be very, very careful. Root 3 and pi is taken common out, 1 over 3 minus 1 over 6. And over here, rule of log is applicable, that is half into root 3 over 2. That is ln of root 3. And this can also be written as half ln 3. And plus minus sign, I'll take care of it at the end again, double checking. 3 and 6 is 18. So this is 6 minus 3. So therefore this is 3 at the top, 18 at the bottom. That is root 3 and pi and 3 over 18. And this is half ln3. Now, let me just double check all my working because the answer is not given there. X tangent x, that makes sense, minus integral of tangent. Integral of tangent is minus ln cos x, so therefore there is a plus sign because of this minus and this minus. So therefore this minus and this minus, that becomes plus ln cos x. Pi by 6 was lower, pi by 3 was upper, that makes sense. X tangent x, pi by 3 tangent of pi by 3, and this is ln of cosine of x, ln of cosine of pi by 3. Okay, now pi by 6 tangent pi by 6, tangent of pi by 6 is this as well as this, and there is a plus sign ln of this thing. That makes sense. Pi by 3 into root 3, tangent of pi by 3 is root 3, that's for sure. Ln of cosine of pi by 3, ln of half, that is a plus sign, minus. Okay, one small mistake over here. This was a plus. When I open it up, so therefore this is minus, this is plus, but this is minus. So this is one mistake that I've seen. And second thing is pi and root 3 is common. So this is 3, second mistake. This is 3 and 6 into 3. I can also take this 3 common out. So this 3 from here, this 3 from here, that is to be taken common out. So few small mistakes are there. Let me correct it. This is division, that I have to take care of. This I have to take care of. So now I'll just look at the final answer. Now no answer was given. That was on my own to check, and these mistakes do happen. So therefore this is pi and root 3 and pi and root 3 and this thing common out. So what are you left with? I am left with a 1 over here. Sorry, I am left with pi and root 3, this is 1. And what are you left with? Pi, root 3 and 3, this is 1 minus 1 over 6. 1 minus 1 over 6 is 5 over 6. Don't forget this 3 on this side. So therefore this thing becomes root 3 and pi and 5 over 18. This much is done. Now over here there is a minus sign. So minus means division. Half divided by root 3 over 2. Plus, as it is ln 1 over 2 into 2 over root 3. So therefore this is plus ln 1 over root 3. Therefore this is ln root 3 raised to power of minus 1. That is minus ln root 3. You can also write this thing as ln 3 raised to power of half raised to power of minus 1. That's minus half ln 3, and this is root 3 pi 5 over 18. Now this looks like a beautiful correct answer like this. That was for 6 marks, and this is question number 4. Let's move on. Question number 5. Understand and label what is this question all about. This is about trigonometry. This is about identity, and next one could be an equation. Yes, it's an equation. So this is an identity and it's an equation. First of all, let's prove it. Show that. Now all of a sudden, what do you observe? You observe cosine 3x, sine 3x. Let me underline them. This is cosine 3x and sine 3x. What do you observe? You observe sine x and cosine x. What else do you observe? You observe cot 2x. Now this is something weird. You have got a 3x, you have an x, you have a 2x. So basically what you need to do is that first use addition formula. So if I open this up, cosine of 3x, and similarly I open up sine of 3x. So what will this become? Cosine 3x, that is cosine bracket 2x plus x. That is cosine 2x, cosine x minus sine 2x, sine x. That's the first thing. Actually, I don't have to do this. There is another trick that just sprung up in my mind. Let me first take LCM. Otherwise, it would become too long. If I take LCM, it would become shorter. Cosine 3x, cosine x. And this is sine 3x, sine x. And this is sine x, cosine x. Now think for a second. This is cosine 3x, this is sine 3x, and this is sine x and cosine x. Cosine x, sine x. Isn't this an expanded form of something? Yes, it is. This is like A, this is like B, plus sine, this is like A, this is like B. So this is cosine A minus B. So cosine A minus B divided by sine x, cosine x. That was the trick. Cosine 2x over half sine 2x. How come? Because we know that sine 2x is 2 sine x cosine x. So only sine x cosine x is half sine 2x. It flips, it gives you a 2, and this is cosine over sine is cot 2x. That was a nice one. If I would have expanded as I initially was doing, cosine 3x is cosine bracket 2x plus x, and then I would eventually reach this stage, but this is a beauty. So this is a nice one that it just sprang in my mind with the color coding, that if I cross multiply, that is a short form of a double angle formula. So basically what I've used over here, cosine A minus B, that is cosine A cosine B plus sine A sine B. So basically I went this way in this particular format. So this question number is done, part A is done. So 2 cot 2x. So this thing is 2 cot 2x. This thing is 2 cot 2x. That is equals to 4. Now it's a simple P1 question, I hope. So therefore, first of all, write this thing as 2. 1 over tangent 2x is equals to 4. That's one approach if you want to go it this way. And then you would say 1 over tangent x, tangent 2x is equals to 2. Therefore, tangent 2x is equals to 1 over 2. That's one approach. Another approach, cot 2x is equals to 2. Therefore, tangent is the reciprocal, tangent 2x equals to half. I think I personally like this approach. Now it's a P1 question. First of all, quadrants, that is first and third. Second step, that is modification of range. 2x lies between 0 and pi. It's a radian question. Step 3, basic angle. Let alpha be the basic angle. So therefore, tangent of alpha equals to half. Therefore, alpha comes out to be, let me grab my calculator once more, and now this would be 0.5. So tan inverse of 0.5 is 4636. That's 0.4636, correct, to 4SF. Now, what are we working for? We are working for 2x. Therefore, 2x is equals to 0.4636. And in the third quadrant, this would be 3.142 plus 0.4636. Are all these answers within this range? Looks like it. 0 to 2x is, this is 2 pi. Yes, they are. Therefore, make x the subject, and each answer will be divided by 2. So one answer would be 46 divided by 2 would be 23 something, and 3.142 plus 3.142 plus 0.4636 added up divided by 2, that is 1.80, and then you get this answer. Let's move on to the next question. The next question is about what? Differential equation. And it says the variables x and y satisfy this differential equation. This is the condition given. Y is 0 when x is 1. Solve the differential equation obtaining an expression for y in terms of x, 7 marks. And then it says state what happens to the value of y as x tends to infinity, that is very, very large. Now that must be for 1 mark. So total 8 mark question. It's not a word problem. This is a question in which we would be working it out. So dy by dx is equals to 1 plus 4y square e raised to power of x. What is the first thing that we do? The first thing that we do in a differential equation question is that we do separating the variables. So when we separate the variable, dy over 1 plus 4y square. So dy over 1 plus 4y square, that is equals to e raised to power of x dx, integrate. Now, do you remember anything, any particular concept that involves this? Now, is it something to do with integration by partial fraction? Is it partial fraction? The answer is nope, it's not partial fraction. Why? Because 1 plus 4y square won't factorize. That is the first thing, that it won't factorize. Second scenario, is it a question related with f prime x over fx dx? The answer is again nope, it's not that, because the derivative is not there. That means this is a question of something to do with that tan inverse integration. So what is that tan inverse integration? So since this was something that is new in the syllabus, so let me take you there, and there might be a table. Let me go to the main one, and this is P3, and this is integration, and this is integration new. This was something we did last time, and let me show you the formula. That is, when we have 1 over x square plus a square dx, that's 1 over a tan inverse x over a. The coefficient of x square should be 1. Let me first go to that paper. The coefficient of x square or y square should be 1. So let me first write this thing at the corner. 1 over 4y square plus 1 dy. I will write this thing as 1 over y square plus 1/4, and I've taken 4 common out, so let me write it on the side, dy, something like this. That is the first thing that I've done. Now after I have done this thing, now again have a look. It should be of the format, this is a square, so 1 over a, x over a. So coming back to this is like your a square. So therefore a is equals to half, 1/4 as it is. And then the integration is 1 over a, and this is tan inverse x over a, or y over half. Got the idea? This is 1/4, this is 2, this is tan inverse, this is 2y. That is the integration involved in this particular part. Have a look closely exactly what's happening. So therefore this is 2 and this thing cancels out. So therefore this integration is half tangent inverse 2y ex. The integral is ex plus a constant of integration c. When y is 0 when x is 1. Y is 0 when x is 1. Half tan inverse y is 0 and e raised to power of 1 plus c. Tan inverse of 0 is 0. So this is 0. This is e. This is c. Therefore c comes out to be negative e. That is the first thing that you get. And then what are you looking for? You are looking for an expression y in terms of x. So therefore half tan inverse 2y is equals to e raised to power of x minus e raised to power of 1. That is the thing that you're getting. Multiply it by a 2, tan inverse, and therefore this is 2y. So this is tan inverse 2y 2ex minus 2e. 2y is equals to tangent of 2ex minus 2e. Therefore make y the subject, divide by 2, and that is your answer. So 2ex, and one more thing to be taken. This is this minus sign. I forgot this. This is minus, and when we divide, there is a minus 1 over here. When y is 0, x is 1. So this is minus, and this is minus 1. Don't forget this. So therefore, this is minus 1 over e. Therefore, C comes out to be, let me do the correction over here. So therefore, C comes out to be 1 over e. And this is e raised to power of minus x. And this is 1 over e, or e raised to power of minus 1 if you want to write it. Minus 1, minus 1, something like this. And that is your answer. Don't forget the minus at the front. Don't forget the minus at the front. The minus at the front. And the e is actually positive, because e was positive over here. So few errors are there. And that's how this question is done for 7 marks. What is it asking? Find the value of y as x tends to infinity. Now let's rewrite y in a better way. That's half. And this is 2 tangent. So there is a tangent. And there is 2 over e minus 2 over ex. What I have done is this. I have written this thing as y is equals to half tangent, and I have written before 2e minus 1 minus 2e minus x, and then I have written e minus 1 as 2 over e, and this is 2 over ex. Got the idea? So that's what I've done. If x goes to infinity, this whole thing becomes infinite. When this whole thing becomes infinite, this whole thing becomes 0. So therefore the value of y is half tangent of 2 over e. That is the answer for this particular part. And leave the answer as it is. Exact form is perfectly fine. Question number 7. Now question number 7, what is this all about? It looks like implicit after a long time, and first part is differentiation, and the second part is tangent is parallel to y-axis. So now that is this thing. So now in this one, what is the rule? X cube 3xy square minus y cube is equals to 5. Differentiate both sides with respect to x. X cube is 3x square, and over here product rule is applicable. 3x into 2y dy by dx, and this is y square into derivative of 3x is 3. Derivative of y cube is 3y square dy by dx. Derivative of a constant is 0. Take this term, and put it on one side. So therefore this is 6xy dy by dx. This is negative 3y square dy by dx. That is equals to negative 3x square negative 3y square. Multiply by a minus sign. This becomes minus, this becomes plus, this becomes plus, this becomes plus. Dy by dx 3y square minus 6xy, that is 3x square plus 3y square. Let's double check the answer. It's very close by. Dy by dx, that is 3 common, x square plus y square. Denominator 3 common, y square minus 2xy. This 3 slashes off. X square plus y square is the numerator. Perfect. Y square minus 2xy, y square minus 2xy. So this is done. What is the second part? The second part is the tangent is parallel to y-axis. Parallel to y-axis, gradient is undefined. If we have a fraction, numerator over denominator is undefined. What makes a fraction undefined? Denominator is 0. So what was the denominator? The denominator was y square minus 2xy. So y square minus 2xy equals to 0. Y common, y minus 2x equals to 0. Y is equals to 0. Y is equals to 2x. Now solve with the original equation. That is x cube plus 3xy square. X cube plus 3xy square minus y cube equals to 5. This is equation of curve. When y is 0, x cube is equals to 5. The two terms disappear, therefore x is 5 raised to power of 1/3. They're asking for the coordinates. That's one option. 5 1/3 comma 0. Is it applicable? We would see it in a short while. Second option, y is equals to 2x. Solve it simultaneously with the equation of the curve. X cube plus 3x 2x whole square minus 2x whole cube equals to 5. X cube 3x 4x square minus 8x cube is equals to 5. So therefore this is x cube. 4 3 is 12. X cube minus 8x cube equals to 5. So many cubes. So 13 minus 8, that is 5x cube is 5, x cube is 1, therefore x is 1. When x is 1, y is equals to 2 times 1, which is 2. Therefore the coordinate is 1 comma 2. I think both answers are acceptable because there is nothing stopping it from getting both the answers. Find the coordinates of the points. Points is plural, therefore more than one answer. So one answer is this, other answer is this. So English grammar is needed in order to understand, in order to make sure that you are on the right track. Now, what is this question about? This question is about vectors. Now, let's look at this question. A box is drawn, some unit vectors are drawn. It's a cuboid. OA is 2 units. Now, let's start underlining. OA is 2 units. OC is 3 units, OD is 2 units. So this is 2, 3 and 2. And the point M on AB is such that MB is 2AM. MB is twice of this thing. So now OC, if it's 3 units and MB is 2 of this, that means this is 1 unit and this is 2 unit. The midpoint of FG is N. The midpoint of FG, where is FG? Is N. So basically this is 1 unit, this is 1 unit. Let's first get rid of all these things. Express the vectors such and such. Find a vector of the line passing through M and N. Find the position vector of the foot of the perpendicular. Okay, it's a wholesome question. Now first of all, I need OM. So OM, start with O, end at M. So OM, therefore let's walk through. This is 2i and this is 1j. So this is 2i and 1j. That is the answer for this thing. So I'll first write 2i plus 1j. It's along the ground level. So there is no vertical movement up. This is 2, 1 and 0. I'm writing it this way also. Second thing they're asking, that is MN. MN. You have to move this much, that is 2j, and then you have to move up, that is 2k, and then 1 unit to the left, that is negative I. 2j, 2k, negative I. So that's 2j, 2k, negative I. Rearrange negative I plus 2j plus 2k. Write it in the column vector negative 1, 2, and 2. That is Mn. So Mn is also done. So 3 marks for this. This is basically part A. It says find a vector equation for the line through M and N. Mn will become the direction vector. R is equals to A plus lambda B. A is position vector of fixed point and B is direction vector. In this scenario, direction vector is Mn and fixed point is M. How about that? You have OM, you have Mn, everything is ready. All you have to do is write it down. So R is equals to something plus lambda something. That vector, the fixed point, that is 2, 1, 0. And the next one is, I think, minus 1, 2, 2. This is minus 1, 2, and 2. That is the equation. This thing is done. Find the position vector of the foot of the perpendicular from D to the line M and N. Do we have D? Of course we have. So we need a foot of the perpendicular. First of all, what is the coordinate of D? Coordinate of D, OD, is basically 0, 0, and 2 because it's right up from O. That's OD. And I need foot of perpendicular from D to line MN. Now remember, it's a 5-step method. Let me draw a 2D diagram for this scenario. This is like M, this is like N, and we have this equation. So R is equals to 2 minus lambda, 1 plus 2 lambda, 2 minus lambda, 1 plus 2 lambda, and 0 plus 2 lambda. This is position vector of any point on the line. Let me first draw it like this. So it's gonna go like this. This is your D, which is 0, 0, 2. This is perpendicular. Let me label this point as R. So OR is this thing, what is written at the top. This is OR, like this. That's the first point to start with. Step 1. Step 2. What is DR? That is OR minus OD. So if I do the subtraction, 2 minus lambda minus 0 is 2 minus lambda, then 1 plus 2 lambda, and 2 lambda minus 2. This is DR, second step. Third step, DR is perpendicular to the line MN, therefore DR dot product with direction vector of line MN should equal to 0. So now remember, what is the rule for dot product? The rule for dot product is if two vectors are perpendicular, then the dot product is 0. So dr is 2 minus lambda and 1 plus 2 lambda and 2 lambda minus 2. Dot product with direction vector of line MN, which is that thing, minus 1, 2, 2. So this is minus 1, 2, 2 should equal to 0. Let's solve. Minus 2 plus lambda plus 2 plus 4 lambda plus 4 lambda minus 4 equals to 0. This is minus 2, this is plus 2, this is negative 4. These two cancel out, take 4 on the other side. This is lambda, this is 4 lambda, this is 4 lambda. So this is 9 lambda equals to 4. Now you are getting a value of lambda as 4 over 9. That's part of life. Fractions are part of life. When you get this thing, you just need the foot of the perpendicular. This method is equally useful for the distance. So what are you looking for? You are looking for R. So plug in place of R. So therefore OR equals to 2 minus lambda, which is 2 minus 4 over 9, 1 plus 2 lambda and 2 lambda. 2 minus lambda 1 plus 2 lambda and 2 times 4 over 9. Simplify, that is the foot of the perpendicular. So when you simplify it, you get something like this. So this OR, which is actually P, this is 14 over 9, this is 17 over 9, and this is 8 over 9. So are they asking for the coordinates or are they asking for the position vector? They are asking for the position vector. So this is basically OP, which I've mistakenly labeled as R. So that's how this thing is. If they're asking for the IJK form, I'll write it in the IJK form. Otherwise, this is perfectly fine. What exactly is this? The next question. This looks like partial fraction for sure. And the next part should either be binomial or yes, it's binomial. So this is partial fraction and binomial, one of my least favorite questions because it consumes a lot of time. First of all, check whether this is a proper fraction or improper fraction. It's a quadratic at the top. It's a cubic at the bottom. It's a proper fraction. So since it's a proper fraction, the checklist is done. Now you start with the case. This is denominator with linear factors. So you will write this thing as 2 plus 11x minus 10x squared divided by 1 plus 2x, 1 minus 2x, 2 plus x. This is identical to a constant over the first factor, another constant over the other factor, another constant over the third factor. Then take LCM. So this is A is multiplied first of all. This is 1 plus 2x, 1 minus 2x, 2 plus x. A is multiplied with 1 minus 2x, 2 plus x. B is multiplied with 1 plus 2x and which one? 2 minus x. Similarly, I'm running short of space, but since I'm using my iPad, I can play around with it. And C is multiplied with 1 plus 2x, 1 minus 2x. So basically, if I color code them, there is a green one, there is a orange one, there is a blue one. A multiplies with the orange and the blue. B multiplies with the green and the blue. And C multiplies with the green and C multiplies with the orange. That's how things are done. Now what will you do? I'll just show you the steps. I won't solve the whole thing. Minus 10x squared is identical to A multiplied by these two, B multiplied by these two. Need more space. And similarly, C is multiplied by the last two. So this is orange and blue, and this is green and blue, and this last one is green and orange. And now you would choose different values. I would choose a value. Let x equals to something. Next one, let x equals to something else. Next one, let x equals to something else. Now the first something else, for example, if I want to find A, so I would choose something that would first, I can go in any order. If I choose 1 minus 2x equals to 0, therefore x comes out to be half. So therefore the orange disappears and I'll be able to find B. If I say 1 plus 2x equals to 0, x is equals to minus half. So 1 plus 2x, 1 plus 2x, I'll be able to find A. And last but not the least, if I say, what is that number? The number is 2 minus x. 2 minus x equals to 0, x is equals to 2. So I'll be able to find the value of C. So that's how you'll find the value of A, B and C in any order. It doesn't make a difference. Next part. Hence obtain the expansion of fx in ascending powers of x up to and including the term in x square. Now the value of a, b and c so happens that a is the numerator of 1 plus 2x. Yes, b is the numerator of 1 minus 2x, c is the numerator of 2 plus x. So let me write each one separately. First of all, the answer for the first part, that is a is the numerator of 1 plus 2x minus 2 over 1 plus 2x. b is 1 over 1 plus 2x. And c is 4, that's 4 over 2 plus x. Expand each one separately. Minus 2, 1 plus 2x raised to power of minus 1. That is one thing. Next one, 1 minus 2x raised to power of minus 1. That is the second one. I think the second one is 1 minus 2x. The second one is 1 minus 2x. And I'll shade it again. Like this. So the third one is 4 over 2 plus x. The third one is 4 over 2 plus x. That's 2 plus x raised to power of minus 1. Now the second thing is this minus 2, let it remain on the outside. No issue. 1 remains on the outside. 4 remains on the outside. Secondly, the first term should be 1. Perfect first term should be 1. First term is not 1. So make it perfect. That is 4 as it is. 2. 1 plus x over 2, the whole thing raised to power of minus 1. This minus 1 is applicable on it, minus 1 is applicable on it. So that's 4 as it is. 2 raised to power of minus 1 is half. This is 1 plus x over 2 raised to power of minus 1. Now it's perfect. So now what will you do? You will expand this. Therefore this is minus 2 as it is. 1 plus minus 1 into 2x and then minus 1 minus 2 2x whole square over 2 factorial, and then you would simplify. The same goes over here. 1, ignore that 1. This is 1 and minus 1 negative 2x and then minus 1 minus 2 and then negative 2x, the whole thing square over 2 factorial. You would simplify this. Over here this becomes 2, 1 plus minus 1 x over 2 and then minus 1 minus 2 x over 2 whole square over 2 factorial. Simplify all these three, add it up, you get the answer. Now let's look at question number 10. Let's hope this is the last question because it's been a long paper. Yes, it's the last question. It says the complex number, and finally the most awaited of all, that is complex numbers. The first part of complex numbers, this thing, it's about the algebra part. So 10a, this is about the algebra. I can see it. You can see it too. The second part is about this Argand diagram and least value and that modulus argument kind of thing. So this is about the loci part. So let's first get started with the algebra. The algebra part is that first of all, what you have to do, there are two complex numbers and it says v plus I w equals to 5, and this is 1 plus 2i multiplied by v minus w is 3i. 6 marks. Solve, give your answer in the Cartesian form. So now if I make v the subject, what happens? V is 5 minus IW. That makes sense. Now once you have made this thing the subject, now plug in V over here. So now 1 plus 2i into 5 minus IW minus W is equals to 3i. Basically we have to make W the subject. So 1 into 5 is 5. And let me use more space. 1 into 5 is 5. 1 into minus IW is minus IW. This is 10i and this is 2w and negative 2i square w. Am I right? This is 2 into 1 I into I square into W, that's perfect, minus W is equals to 3I. 5 minus I W plus 10I plus 2W minus W equals to 3I. Take all the W's on one side. 2W minus W, that's W, minus IW, that is 3I minus 10I minus 5. Let me double check. This is minus IW, done. This is 2W minus W, that's done. This is 10I, this is 5, negative 10, negative 5. That is also correct. Okay, and this 3I was already there. Okay, so this is all there. So therefore W common, 1 minus I equals to minus 5 minus 7I. And make W the subject, that is minus 5 minus 7I divided by 1 minus I. And should I rationalize it? Definitely you should rationalize it. So therefore multiply and divide by conjugate of denominator, that is 1 minus I, 1 plus I, 1 plus I. The conjugate is 1 plus I. So therefore this is minus 5 into 1 is minus 5, minus 5 into I is minus 5I, minus 7I into 1 is minus 7I, and that is minus 7I square, which becomes plus 7. Divided by 1 square plus 1 square. So 7 minus 5 is 2, minus 12I divided by 2, that is 1 minus 6I, that is W, after so much of calculation. Once you get hang of W, now evaluate V. So V is simply 5 minus I into W, 1 minus 6I. That is 5 minus I minus plus 6I square, but I square is minus 1. So minus 6 plus 5 is minus 1 minus I. So therefore V is minus 1 minus I. So these are the two answers. V is minus 1 minus I, W is 1 minus 6I. So that is the calculation for 6 marks. Let me move to this one. On an Argand diagram, sketch the locus of points representing this. First of all, modulus on one side, constant on the other. So what is it? This is a circle, and there should be a center, and there should be a radius. So z minus 2 plus 3I modulus equals to 1. Therefore this is of the format z minus a plus bi modulus equals to r. Center a comma b is 2 comma 3, and radius is 1 unit. That's the first thing. Calculate the least value of argument of z for points on this locus. That means what you have to do, you have to calculate something that is related to angle. So first of all, let's draw this. And this is a x-axis and a y-axis, actually a real axis and an imaginary axis. This is imaginary, this is real. 2 comma 3. So this is, let me draw a circle first, an empty circle. So this is 2 comma 3, and the radius is 1 unit. So let me draw a small one. And somewhere over here 2 comma 3 is like this. So this is 2, this is 3I, and this is the center. Now what is it asking for? Calculate the least value of argument of z. Argument of z is a half line, and it's originating from origin. It's starting from the origin. And the least value would be what? The least value would be something like this, just touching this thing. Let me make it even more thinner. So the least value would be like this. Now if I want to find this least value, I need to focus a bit on the diagram itself. So if I draw a purple line like this, and then I draw an orange line like this, so now it makes sense. This is origin, this is center, this is A, and this is right angle. So if I want to draw it, I think that would be too risky for me to draw it. So let me draw first of all a green line. So the green could be the base, and the purple one is like this thing, makes sense, and then an orange one like this. So a beautiful diagram is needed. That's the need of the R. This is O, this is C, this is A, this is 1, and this is 2 square plus 3 square because of Pythagoras theorem. So therefore 4 plus 9, this is root 13. This is right angle. Let me label this thing as theta. So tangent of theta is 1 divided by root 13. So going to my calculator, and root 13 and reciprocate it, and I'm changing it into the degree format, and tan inverse, so this is coming out to be 15.50 degrees. So this is 15.50 degrees, that is this angle. Which angle? This is this angle. Now if I focus on 2, 3 itself, so now let me focus on the other triangle, which is like this and like this and like this. So this is the 2 and the 3, and this angle, let me call it beta. So tangent of beta is 2 over 3, therefore beta is, let me first change 2 divided by 3, and then tan inverse, that is 33.69 degrees. That is this angle. Now what is happening is that this angle is theta. No, it's not making sense. This angle is theta. This whole angle up till here is beta. So this is the angle that you are looking for. That is the difference between theta and beta. So difference between beta and theta, that is the least value of argument of z. So therefore this is 33.69 minus 15.50. This comes out to be 18.19 degrees. So this 18.19 degrees, let me double check it if this answer makes sense. First of all, calculate the least value of argument of z for points on this locus. First of all, the circle is there, that makes sense, and then least value would be from the half line. So 2, 3 was that angle, that is 33.69, and this angle is 15.5 degrees. That is, oh sorry, one small mistake. This is not tangent, this is sine. So let me change my working over here. So therefore 1 divided by root 13. So this is 13 square root, reciprocate, sine inverse. This is 16.10 degrees. So this is 16.10 degree, and this is 33.69. But one other thing I want to be sure of is that the diagram is all good, because this angle is based upon 2 and 3. So therefore this is tangent. This is 33.3 over 2. My bad, one other mistake. So that is not 2 over 3, that's 3 over 2. So this one is 3 over 2. Again 1.5 tan inverse, that is 56.3 degrees. So that is 56.30 degrees. And now take out the difference, 56.3 minus 16.10. So that is 40.2 degrees. So the answer is 40.2 degrees. That is the least value of argument of z. So now this is P3, and it takes time and dedication and courage to do a whole paper. So we are done with February, March 2020, one variant, and see you next time.